No worries.
Hello.
I'm recording. Hey.
How's it going? Wait, can you guys hear me?
Yeah.
Okay. Okay. Yeah. So, Chris, I guess status updates. Chris did diagnostics. I think there are only some comments left, which reminds me I need to say close another open Rust ticket to improve closure diagnostics. So we got good stuff done there. We have a bunch of questions regarding the audit rate stuff because I think Roxanne
Yeah, I
looked and
saw
I
the
looked.
clone question.
Yeah, there's that. And also we could not find rates defined for send and like def IDs of rates for send and unwind safe.
Unwind safe and unwind safe ref, or ref and unwind safe. I can't remember where the ref is in that sentence, but yeah.
Okay.
So basically, yeah, we don't have things for send right now because of that. And third thing that's left is Rob and yeah, those has exams. The only thing that's left is like small comments. It won't be long after today or tomorrow. I think he's done today or tomorrow with his stuff.
Okay. Do we want to just go through the questions?
Yeah, I think that
And
would be easy. Yeah, maybe Roxanne shares her screen and
Yeah, no, I can do that. I might need
I'll have to give you
access.
permission though.
Yeah.
God
My
dang.
tabs are so unorganized. Now I just need to refine everything. Yeah. Let me try that again.
I can open it if you want, but I don't. I think it's better.
No, I have it.
Right.
Can you all see my screen?
Yeah.
So like I've been looking through the language item table because it seems like for everything else, like the sync trait and the clone trait, we can find the def ID just by calling like
You're saying you can't find the send trait in there?
No, I can't. I can find the clone, the sync trait.
Gotta be in there somewhere.
Yeah, I've been even like searching the whole repo and I can't seem to find anything. I do know that there's a
you know
symbol.
what? Oh. It might not be in there, actually, because there's really been no reason for the compiler to know about the send trait. It's just an auto trait, and there's logic that works for all auto traits. I bet it's not in there. Yeah, I think we have to add it, along with probably the same with assert, unwind safe, or whatever else. Yeah, same thing. Those are all like library invariants that the compiler doesn't have to be involved in.
I tried to add a new row, but I'm not sure what I have to do. Is there some other things I need to add apart from adding a new row in that table?
I don't think so. I think you can just copy and paste the sync to make a send line.
I think
I tried to do that, but it seemed like it wasn't fully like working. Maybe my test is wrong for send. I don't know. I guess I'll take a look and make sure that.
And did you add the lang item annotation to the declaration? That would be something else you have to do.
I don't think so. Where would that be?
Okay, so if you pull open, hold on, I'll send a link in 2 seconds. So, right. Sorry, where's my Zoom window? Zoom. Chat. Okay. Click this link. So now, okay, that's where the send trait is declared. If you scroll down, scroll up or down, or somewhere here should be where the sync trait is declared. Keep going up, go back up again, a couple lines. Ta-da! Okay, look on line 464. See that? You need something like that to tie it together.
Oh, okay, that's probably what I was missing all along.
Yeah,
Okay, I guess I'll try that after our meeting.
Yeah, if you have problems,
Um,
just ping me. I can try it, or like push a branch somewhere and I'll take a look. There might be some other silly things that have to be synchronized, but
Okay, yeah. And I guess like the other thing that I kind of realized is like I guess like as I mentioned like a few days ago, like it seems to me like the clone, or I think it could also be applicable maybe for other traits that we're checking. But like since we're only checking if the root variable is applies a trait and if
yeah,
the field doesn't,
yeah,
like I guess yeah.
it applies to everything, I think.
Mhm.
There's a bit of a trick here. So, okay, clone is particularly, okay, so let me back up. Your point was, we're checking whether you implement the trait or not, but we're not checking whether you needed to implement the trait.
Yep.
And you felt like there were a lot of false warnings or like false migration, ugly
It wasn't
migrations because of that, correct?
it wasn't really like false migration. It's more like I guess I'm more concerned that like in the case where like a lot of things do implement the clone trait, we just end up like providing a lot of warnings for like things that may not need,
Yeah,
like that the
yeah,
user may not care about, and it would just
right.
clutter it. I don't
Yeah,
have a great example of that, but
we'll just produce unnecessary migration instead of just letting the code work naturally. Yeah, that's possible. I was assuming that the rate of false warnings or unnecessary migrations would be low, but I don't have any basis for that. It's just a gut instinct or something. So, okay, there's two things going on. First is for the clone trait is special because anybody that needs the closure to be clone basically has to be locally visible. Like within the function that created the closure, somewhere in there, it has to test for it to be clone or no one will ever be able to test. And that's because the only way that somebody else could get a hold of that type pretty much would be by it getting returned from the closure. And in that case, it would have to have a type like arrow impl something plus clone. And so in fact, sorry, not return from the closure, return from the function. And it would have to have an arrow impl plus clone, which means that we will be testing if it's clone within the function body. Does that make sense? Would it be helpful if I had a place to type?
yeah, it might be helpful.
Let me put up or do you have a hackmd or something on one?
Not for this thing.
I can make one.
Not for Octave. Yeah, we can either do that or we can put that in where the rest of the migration stuff is in like the 2020 status.
Well, for
page.
now, I'll make
Okay.
I'll make one, but we can copy the content somewhere else later. Let me share this screen. So, unnecessary migrations. So I think the problem statement is something like let x equals, or let closure equals, I don't know, something that's not clone, or something that is clone wrapped around something that's not clone.
Yeah.
And this would be something like, and right, if we have some function like this, it's true that this closure would no longer be cloned. It's also true that nobody cares. Right. So what I was saying was, if anyone is going to care that the closure is clone, it will be the closure creator must care. And there would be a couple ways that that could happen. One would be like, like this. But another might be, let's make this self-contained. Another might be like this. And here it's like, we're telling our caller that the closure we return is clone. But the point is that either way, at the point where we return C, it's our job as this function to prove that C is clone for our, so that our caller can rely on it. And what that means is actually during the type check, we have a kind of record of all the things we had to prove along the way for this particular function. And so we could conceivably remember things like anytime we had to prove that a closure was clone, let's remember that, because then we might want to lint about it. And if we don't see a record in there that we ever had to prove that the closure was cloned, then we can leave off the lint. So
I have a thought about one edge case. So let's say the user did have a call to let's say c.clone somewhere. But before they ran the migrations or before they were doing something, they did comment it out for whatever reason. They were trying something out, like could be anything. It is possible that we do not, like, user does want the clone call, but at some point they decided that for whatever reason, they're testing some part of other code. They don't want this to be involved. They commented it out. They do the migrations, they uncomment it.
Yeah, that could happen. I don't know.
Yeah.
Cry me a river. We didn't promise you that some future variation of your code will still compile. We just promised you that this one would.
Fair enough. Fair enough.
Yeah, it's a question of how often does it happen that, like, how often does this scenario happen in the first place? I think my assumption was most clone things have not clone things, or don't have not clone things in them.
Yeah.
Or at least if they do, we're either capturing them by reference, in which case it doesn't matter because the reference is clone, or we are capturing the outer thing. So like if you imagine, as an example, if I said, let x equals RC new, not clone, this is probably pretty common. Now the x is clone, but the stuff it guards is not. However, we can't take the stuff out of the RC box, at least not easily. Yeah. So we're not going to move it out. We're either going to capture ampersand x.0 or we're going to capture x.
Actually, question: does when we do is box checks on our types, does RC show up as true? Because if not, then we're not. Yeah, then we need to deal with that scenario, because all our code only deals with is if we have a box type.
You're probably right that in fact we'll always just capture the RC because it's got a deref or whatever else. But that's okay.
No, that's what I'm.
It's an overloaded deref.
My question is, do we see that as a? Oh, it's an overloaded deref. It's an overloaded. Okay, sorry, I see.
Yeah, it's okay. We're actually. That's just a limitation of the type system, and can live with that. Box is special. Box is the only type right now. Box is the only like non-sigil type, that we get to see through like that.
Okay.
So that's true. So this could happen. There could be unnecessary migrations. I think we could fix it. What I was going to say is that there's a difference, however, between clone and auto traits. The problem is for auto traits, we have something we call auto trait leakage. And in particular, it's allowed for me to write code like this for better or worse. Better a lot of the time, but not always. This is one of those not always situations. If I call variant 2, this code would actually compile. And even though I didn't write impl fn once plus send, this will compile, assuming this is send, of course. Let's just make it send by to trivially send now. So the reason is when we're testing whether an auto trait holds, we actually don't use the like opaque type where all we know is that it implements fn once. We actually test it against the underlying type, the hidden type. And that's basically because, well, that's kind of what auto traits do, is they leak. That's their whole reason to exist, is to be convenient. So they leak out through privacy and other kinds of boundaries. And the point being that when we're type checking variant 2, we actually can't know whether one of our callers cares or not if the closure gets returned or otherwise passed outside of the function, because there's another variant like this. Well, okay, this variant is not so important. I take it back. I was going to say something like this, but actually we would have to write send here for us to do this error. So actually it's not true. It's really only the returning case. So if we wanted to be super precise, we could detect the case where the closure gets returned somehow. And so if we wanted to be super precise, maximally precise, we would say, consider an auto trait X if we see a test for closure X, or let's say AT, or closure type C is returned. However, sorry, I'm stating this weirdly. Consider whether a closure type C. However, you know, migrations don't have to be perfect. Our aim is to get 90% of the code out there automatically migrated or something. And my hunch is we could just ignore the second part and it would work pretty well in practice.
I think it might also be safer to ignore the second part than not. Like,
Right.
Basically, if we miss something, then we are not migrating everything we possibly should have.
Right.
Whereas if we do it, we will. If we don't do it, we will migrate things that we probably didn't really need to, but it's still working code.
Yep. Yeah.
Semantically the same.
Yeah.
Yeah, I mean, basically, if we consider the second part, we're still going to have unnecessary migrations, just fewer.
Mm-hmm.
Whereas if we only consider the first part, we are only producing necessary migrations.
Mm-hmm.
Would it be better to start with like maybe providing too many unnecessary migration and then see what other people think and then address it if it's an issue?
Yeah,
I don't know.
my opinion is, I don't have an opinion, is my opinion, or like that it's kind of a database question for me.
Yeah.
I think in my ideal world, we would run a crater run. We would see how often we get unnecessary migrations according to various, you know,
Actually,
tests, and how often we would see two factors, like how many migrations do we consider unnecessary? And if we only do the ones we know are necessary, how many compilation errors do we get? And we would make a judgment based on that.
We can enable this lint by default, and let's just build stage 2 of the compiler and see how many times the compiler throws.
Yeah.
Might be an interesting point to start with.
Yeah, that's an easy one to test, especially because the problem is it's actually hard for us to get the number of problems metric, even with Crater and infinite time, because some of the code is libraries and we don't know all the code that uses those libraries. So like there may be cases where it was important that we keep the thing that the closure type remains send, but we can't see it.
Is it possible? I guess it doesn't really matter. We can just, yeah, I was gonna say maybe we can like, oh, yeah, just couple small things that are part of the Rust toolchain we can just quickly build. Though they'll probably get built as part of
Yeah,
building.
I think just
Basically.
doing a handful of tests would probably give us enough data to make
Yeah.
a judgment. Like, it
Yeah,
doesn't have to be all of Crater. If we just try it on first try on the compiler, maybe that'll already tell us because it's already like,
pretty
you
big.
know, thousands of changes and only 1% are necessary or something. Well, okay, done.
Mhm.
So I suspect the compiler is representative. Yeah, compiler probably doesn't care
There's only
about things
one
being
spot.
sent very often.
There's only one spot in the compiler that I know we need to actually migrate, and that's about it. So it's
Didn't we already migrate the compiler?
No, I only did that for the testing part. I think I do not remember. I might have not. There was only one spot I know that needed an actual migration. Oh, I did not because my commit had a lot of other unimplemented features bugs being worked out around.
I see.
So yes, should be exactly one warning.
What I would recommend is, yeah, first version is, maybe you've already done this, but if we implement it implement it so that it issues the maximal number of warnings, that's like the easiest thing to do.
Mhm.
And then we could consider the case where we filter them by what we actually see being demanded, which I think would be a fairly small addition.
Mhm.
Yeah,
we can
I
also
guess.
do this in. Go ahead.
Oh no, you can go ahead, Aman.
Oh, I was going to say we can just do this in two parts. Just like one is get this out, maybe even have people sort of. I know there are a couple of people who have tried this because we had a bug at one point, which is nice in some way. So it might just be a good idea if like actually if someone actually uses it and tells us, oh, this broke or this happened. So.
Right. So if we just implement the maximal, we get a total number of migrations. And I think there's also my hypothesis, which I started with, was that number would actually be small. Like that most of the time, if the outer thing is send, the inner thing will be send, and vice versa. And it's rare to transition that way. And if that's true, then none of this matters at all because it's like fractions of a small number is still a small number.
Yeah.
Yeah, that's all I have on my questions. I don't have too much other than that.
Okay. Great. So we'll start with the first one and then worry about the rest.
Yeah.
So what else is going on here? Oops.
All right. Yes.
We got
This
these are kind of close to being ready.
Everything that's in progress or in review, except the blog post because I forgot to put my changes, and I'm sorry. Yeah, but other than that, everything that's in those two columns are near done because all the diagnostic stuff you reviewed, from what I understand. So we're basically feature complete, except for maybe adding some more test cases to the compiler, but nothing major is left from an implementation point of view.
Yeah, great. It's amazing.
Yeah,
Super exciting.
So we basically now need to do our credit runs analyses and then work towards the polish complete stuff.
That's so cool.
Yes.
Can't wait to use this.
Yeah. I mean, it's still usable.
I know.
Yeah.
Not in the code I'm using. Problem is the code I'm using is mostly unstable only. So I'm gonna have to wait a little while still. But
yeah,
we'll get there.
We'll get there. Yeah. Is there anything for us from addition team or lang team that we need to worry about given deadlines are coming up soon for that?
No, I mean, we're well on track, I think, to meet the implementation deadlines.
Yes.
They're also not, they're a little, they're there to cull out stuff that really isn't making progress. If it's close but not quite done, well, I'm not gonna say, oh, forget it. We got an extra week or two. But I think we're our goal was to have migrations and
diagnostics part of the feature complete.
Yeah.
Yeah.
And everything here is
that is
polished except for this one thing.
Yeah.
Which is not even particularly important because async closures are not stable.
Oh, okay, nice. They work. It's just make sure the compiler runs the test every time.
Right. I guess I think we could recategorize that as polished, given that they're not stable.
Fair enough.
In other words, so therefore,
your feature
right now.
Yes, we are very near feature complete. I like this.
Ta-da! That much closer now.
Yeah, that much closer.
That's how
yeah, we can actually move all of that into in review as well, just so that we get a larger purple bar.
My experience is that every deadline gets met this way in practice. Oh, those bugs look hard. Let's push that to the next milestone.
It works. It works.
All right,
the method works. It works. Not the functionality, I suppose.
Then,
all right. Yeah. I think that's.
Then we'll talk next week, I guess. And
yeah,
let me know when these are ready for my review, and
yeah,
I'll try to be snappy about it.
We'll probably also see you Monday.
Yes, we'll see you Monday.
We'll see you Monday. All right. So yeah.
Bye.
Bye.
Bye.